Now let's do another example of creating constitutional isomers given a molecular formula. So in this example, we're going to have more atoms. So this is C5, H10, Cl2. We have more atoms to combine, right? So 1, 2, 3. We're going to do a line first, and then we're going to start doing other things. 1, 2, 3, 4, and 5. And just to begin, we're going to do this one. And here, then let's see, how is the connectivity? What I see here, I'm going to name this carbon 1, 2, 3, 4, and 5. And I see that the chlorines, the two chlorines, are attaching carbon 1. So I'm going to say this is 1,1 dichloro, chloro, and this is pentane. All right, now let's connect things in a different way. And I'm going to do 1, 2, 3, and 4. And I'm going to make that. And then I'm going to complete all the valences. So I'm just did this, say, random. And now I have, let's see, 4 carbon here, another carbon here, that's 5. And so I have all the atoms, but now this is a different compound. Notice that on the line here, I have 1, 2, 3, and 4. And now I have this attached to, say, the parent chain, the longest chain. So that one is totally different compound because atoms are connected a different way. This one is actually, the parent chain is called butane. And now we have in the carbon number 1, we have a chlorine, so 1 chloro, 3 methyl, and I run short of room, so I'm gonna do it below, or do it again. That's 1 chloro, 3 methyl, butane. The point here is that they have different connectivity and they will also have different names. So we can try other things, other way to connect these compounds. Let's say that I have now 1, 2, 3, and now I have this. And I can do my chloro here. So notice that there's, the more atoms we have, the more possible combinations. So more atoms, more constitutional isomers. So here, this one, I'm going to number carbon number 1, 2, and 3. And now chlorine is still attaching carbon number 1, but now we have some ramification. Things are different. The longest chain actually is now this one, which contains 3 carbons. Here the longest chain was this one, which contained 4 carbon, and here is obviously that. That's a straight line. So now this one, we're going to name it differently. This is propane. So the longer chain has 3 carbons. But now I have in carbon number 1, I have a chloro. And then in carbon number 2, I have 2 methyl groups, which I'm going to circle. Let's identify that. So that's 1 methyl group. And this is another methyl group, right? So when we're naming that compound, now we're going to say that this is 1 chloro. And then in carbon 2, I have 1 methyl and another methyl. So I'm going to say 2 dimethyl. I ran out of room again, dimethyl propane. Point is, again, same molecular formula. Atoms are connected in a different way, so they are constitutional isomers and will also have different names. Now let's do one more thing here. I'm gonna erase one of these to show you something different. See if we can identify that as constitutional isomer or not. One. And let's see. Now I'm making a different drawing, right? And remember that I need to keep 5 carbons. 1, 2, 3, 4, 5. Now it seems like it's different, but we're going to number now the carbons. So let's say 1, 2, 3, 4, and 5. There are no ramifications. We only see that this is like if I have this string and I pull it and bend it. And this is exactly what I did here. Now, chloro is still attached in carbon 1. So this name does not correspond to that. It was a molecule I had before. The name of that is what we said before. So 1-chloropanthane. And here I see that chloro is also in carbon 1. Only that here I named carbon 1 on that side, and now it's on this side, but it's the same thing. So 1-chloro and 1, 2, 3, 4, 5. Panthane is the same. So notice that they are just two different pictures of the same molecule. In fact, we're going to learn later that there are things like that which we call conformers, or different conformations of the same molecule. This is the same molecule and has the same name. We'll talk more about constitutional isomers in another video.